Perfect. So let's start the next module, guys. Okay. So from today, as discussed, we are going to start a new module called as statistics. Simply stats. Okay. Fine. So now, before going into different dimensions of statistics, first let's try to understand what is statistics and why we need to study statistics and how it is going to help us in our machine learning journey. Okay. So see, what will be our ultimate goal? So as I said, from this class, whatever you are going to study, so that you will be able to apply directly to your machine learning concepts. Okay, Python is also applicable. Okay, but Python will still come under a normal programming language. Okay, to tell you a funny thing, so we have studied Python, we have covered different concepts, that's fine, but most of the companies, right, they don't care about the programming language much. Okay, they might just ask you one or two questions here and there, in that is in case if they want to test, or else they will take it for granted you are good in programming language. Okay, mostly for the experienced people, but for freshers they might keep one round. Okay, for Meghana and Sirish, I think you might face like one round at most on programming language, but for experience they will not focus much on the programming language. Okay, but what they actually focus is on stats, machine learning part, feature engineering part, your project part, etc. Okay, so now coming to stats, right? So as I said, our ultimate goal is machine learning predictions, right? So what are we doing here till now? So what all we are going to study, everything should end up somewhere in the machine learning part. And what is machine learning we'll be seeing in detail in coming classes, but just to give you an idea, right? So it will help us to predict something. That means you will give an input. Okay, since you guys already have some touch, okay, some background around the machine learning, so I'm telling. So it's like whenever you give an input to a model, okay, we call machine learning model, right? So it will give an output. Fine. So in simple words, that means this input should have some connection with the output. Agree? So this input should have some connection with the output. Only then, if at all giving you a certain input, you will get a certain output, right? If there is no connection at all between input and output, correct? So obviously there is no point in doing all this. Just to give an example, if you give an age, right, you will be able to predict salary. Okay, that's fine because there is some relationship between age and salary. As age increases, salary might increase. Okay, something like that. But designation will also have some relation between salary. But name, what does name have some? Does name have any relation with salary? No, that does not make sense, right? So obviously, as you can see, to study some relationship between, right, inputs and outputs is extremely important, because that's all what we are trying to do. Okay, do some predictions, do some, okay, clustering, we are going to see that. Okay, so now what I'm trying to say over here is it is extremely important, okay, to understand each individual column behavior, its nature, its distribution, its type, what type of data it's having, what is the range of data it's having. So it's a complete properties of each individual data. Okay, similarly complete properties of each individual another data. Okay, so what do I mean? That means in your data you don't have one column, you don't have single input and single output, right? So you might have tens of input. Okay, you might have tens of input and you will have only one output. Output will always be one. Fine. So just as an example, so if your use case is to predict salary, okay, your input might be age, as I said, designation, okay, as I said, your ratings, okay, and as I said, your uh, there might be some index like overall your appraisals. Okay, there might be some factors which are influencing this output. Okay, So now obviously you should have decent knowledge about what does each column is doing here. Okay, what is its distribution, right? What are its properties? Fine. And also what is the output type? And is there any relationship between this first column and the output column? Okay. So those things you should be able to understand, right? So before going there, you should build up some skills, some foundation, so that you are given a new single column or given some data. Okay. For that matter. So initially, so we'll go step by step, guys. Okay. So given some data, some group of numbers, some sequence, a list of numbers, okay, you should be able to know some properties about that. How does, if I plot that, how does it look like? What is its shape? Is it falling into some distribution? No. Fine. If it is falling, then what is that distribution? Fine. If it is not falling, then why it's not falling? What numbers are deviating it or stopping it from falling into some distribution? Okay. So all these things you will be able to understand. Why? Because only when you understand you will be able to analyze these things. Fine. So now that is the reason stats is the fundamental things. Okay, stats is a fundamental things, but stats is just a path which will take you to the end goal. Okay. Okay, it's like, let's say it's like a road, guys. Fine. So you have started with Python. Okay, you have started with Python. Okay, you have collected a single let's say a weapon. Okay, one tool. Fine. Now you are going to collect one more tool called as stats. Fine. But with stats you cannot do anything. With Python you cannot do anything. Okay, just because you know Python you cannot go and attend interviews. Okay, even if you study stats you cannot do anything. Okay, so why we are studying this? You are collecting tools. Fine. So that all this will be available to you, because once in future modules, if at all you are given a data, right, you should have 360 degrees understanding, different types of tools and techniques to grill down this data, understand its complete behavior of each and every column, and only then you will be able to decide which particular machine learning model to use. Fine. So as I said, everything should end up somewhere. It should be useful somewhere in your machine learning model. Okay, in machine learning concepts. Otherwise, why you will study, right? Because that's the reason. That's the reason. Stats is like ocean, guys. Okay, stats is like ocean, right? So they're like 1,001 topics. Fine. So those are all not needed for us. Okay. So we are going to study what all stats that are required for ML, because our goal is ML. Okay. So we are going to see ML. Okay, we are going to see stats from ML point of view. Okay, let's say we are keeping ML lens, and from that lens what all stats, okay, in that radar, okay, in that radar what all stats needs to be covered, we are going to cover each and every concept. Okay, so then what I'm saying, so everything you're going to study in stats, right? So those will be extremely important, and those are extremely needed, okay, for you to decide on many things, right? Because I tell you guys, as I said, from today you are going to come across many new concepts, new words, new terminology, right? So it will be very interesting, and if you are okay, you can, after the class you can go through the class and start making notes. I would strongly recommend that because while going through the class it might be very easy, but you will forget. Okay, as a human beings we usually forget, okay, because some of you might be studying, some of you might be working, so you will be busy in 101 things and you forget. Your brain usually forgets. Okay, so but coming to stats, right? So I'm saying stats is not that easy. Okay, on day one itself I'm giving you some precautions. Okay, I'm not scaring you, but stats will not be that easy. Okay, it requires much focus and attention. Okay, because it's not something like programming language, you don't have touch with that. Okay, programming language you might already studied, at least C you might have studied. Okay, irrespective of the branch, which branch you come from. But stats, okay, it will be like there will be like a lot of new concepts. Fine. And as I said, there should be some continuous studying for stats. Okay, but is coming to me, I only studied stats at least 3 to 4 times, the complete stats. Because first time you study, you feel you will understand. Second time you study, then you'll understand you will not understand anything. Fine. Third time again you will come back and you will study. Okay, slowly you will start understanding stats. Okay, and a lot of people who are like who think they are good in stats, right? So they will study like stats like multiple times, right? Stats is itself is like that. Okay, so it takes some time to for the concepts to slowly digest, okay, inside you. So but having said that, I will make sure that to go step by step and make sure you understand it in the most easiest possible I could do. Okay, so but only thing you guys needs to do is you should not miss the classes, because once you miss the class, right, so there will be a disconnectivity. So once that is there, right, so again it will take some time. It's not like Python programming language. Okay, even if you miss some class, let's say loops, right, fine, you can come back and study that, but it will not affect your next class, right? So even if you miss loops, you can still understand exception handling. Okay, even if you miss exception handling, you can still understand file handling. Okay, that's fine. But here there will be like almost linked concepts will be there. Okay, there will be continuation classes. Okay, so if one link gets missed, then it will be difficult for you to continue, and then you will lose interest in stats, right? You will think, okay, I'll see later, I'll see in the weekend lo chudamle అని అనుకుంటూ ఆ weekend లో చూడవు. So you will miss like 3 to 4 classes, and that will create a mess in your mind, I'm telling you, because once you get scared with the stats, then it is going to be very difficult. So that's why on day one, and if you're good at stats, right, then you will be king in ML, because ML itself is stats. Okay, earlier when this data science was actually invented, right, so initial days, so data scientists are called actually statisticians. Okay, data scientists are actually called statisticians. Then slowly then they started to work on like more and more data and new ML algorithms all together, right? So then this new term called data scientist came into picture, but earlier they used to call like statisticians, etc. Because I'll tell you one interesting thing. When we are studying machine learning, right, I will show you machine learning is the code for machine learning is nothing, right? The code for machine learning is nothing. It's just 10 lines of code, simple code. So right from there will be, just to give an idea, there will be like different steps. Okay, so let's say first will be you will collect the data. Okay, because from this class, so as and when required, so I'll be jumping from stats to some part of machine learning. Okay, so that you will have some exposure to ML concepts also, right? So that when we come to ML, right, so see, you guys might already have some knowledge about ML, but I am going to assume that you have zero knowledge about stats, zero knowledge about ML. Okay, because I don't know how much you are good at ML or stats. So let me assume, fine, I'll completely assume that you guys don't know anything about stats and don't know anything about ML, right? So that's why as and when required, so I'll be shifting some time to ML and give you also exposure like where you guys can probably use this and why you're studying that. Okay, so now first thing is in ML, what will be your ultimate goal? To do some predictions, right? So for that you will be at high level, so there will be different steps involved. So one is data collections. Okay, second thing will be what you are going to do. You'll do some data pre-processing, you will do, okay, or cleaning. Okay, let's say you will clean the data. Okay, third will be you will pre-process the data, fine. Fourth thing will be what after pre-processing you can do some feature engineering sort of thing. Okay, and after that fifth thing will be splitting the data. You'll split into train data, test data. Okay, after that splitting, you will what you will do, you will do the training. Okay, after training, what you will do, you will check the accuracy. Okay, if accuracy is good, what you will do, eighth thing is you will do the predictions, fine. So once you get the good prediction, that's fine, you will deploy that model. Now all these steps, right, from data collection to prediction, right, so this can be done in less than 10 lines of code. Literally just 10 lines of code using any machine learning algorithm for that matter. Okay, you can complete this. So code wise, it's not that difficult. It's nothing actually. Code wise, even a person who does not understand ML also, he can code it. Okay, at least the basic ML, he can just go through the code, understand, and just start writing code, right? That's fine. That will be very easy to do. Okay, but that is not why we are doing this. Okay, just to build a model is not our purpose, right? And nobody care about building a model. Fine, if you're able to build, that's good skill, that's fine. But even in interviews also, even inside the companies also, nobody will be impressed if you're able to build model. You should be able to understand behind the scenes, right? That is extremely important. And your interviews, you will be completely focused on what's happening behind the scenes. Okay, if you say the questions will be like this. See, I'll give you an idea. So you are going to do this in data cleaning. You can use 10 different types of data cleaning. Okay, you can do different types of pre-processing. You can do different types of feature engineering. Okay, you can do splitting will be same. Training, you can use different types of ML algorithms. Okay, you can use different types of accuracy metrics. Okay, predictions will be always same. So now wherever you see these different types, right? So now obviously you need to answer. Before answering, when you're building, you need to take a call which type of data cleaning you should do, right? If there are 100 ways of cleaning for every data, you cannot sit and do all 100. It is waste of your time, energy, effort, right? Based upon the data, based upon your requirement, based upon the ML algorithm you are trying to solve, you should be able to understand what type of data cleaning I need to do, what type of pre-processing steps I need to follow, what type of feature engineering I should include, and ultimately what type of model I should use for for this type of data, right? So that is coming from where? That will come from your understanding of the data, right? And understanding of the data will come from where? Your stats. Okay, actually stats is a fundamental thing. With stats you will be able to understand, you will be able to visualize. Even if you don't, if you're not, by directly seeing, nobody will understand, right? You might get some 10% of the uh, knowledge or information, but there are different tools and techniques using Python, right? So now you will see. Now since you have collected one tool called as Python, right? With that you will be able to use that in stats, and try to see some distributions, see some visualizations, see certain properties, see some correlations. Okay, a lot of things. After studying stats, now you will have two tools, Python and stats. Using these two tools you are going to use, let's say, in NumPy or pandas, okay, or matplotlib. After that you have five tools. Using all these five tools you are going to study something called as feature engineering, okay, or EDA. With these seven tools you are going to study the ML. Fine. So it's like you are, as and when you are going forward, right, you will collect different tools. Okay, you will make sure you are comfortable with that, so that finally you can play with the ML algorithms or ML concepts. Fine. So that is the concept I would like to mention over here. And yeah, so just coming back, so to have comfort levels with these concepts, right? So as I said, building the code is very, very simple. Okay, so what's happening behind that? You need to answer. Okay, they will ask you, hey, that's fine, you are very good, simply you are building, but why did you consider only this feature engineering step? Or tell me properties of this first column. Okay, what is the correlation between this with the output column? How did you know that you should only go for this ML algorithm? So let's say we are going to study like 10 ML algorithms. Okay, 10 ML algorithms. And if at all you are using, so using any algorithm, you can get accuracy, guys. Right? Any algorithm you give, it will, whether it is good, bad, ugly, that's different. Okay. If you use an ML algorithm, obviously it will give you some accuracy. So if at all you are using a particular algorithm and if you are getting some output, that's fine. But the question will be, why did you choose out of 10 algorithms? What made you to choose this algorithm? Why did you feel that is going to give you the best accuracy? So these questions you need to answer. If you are not able to answer these questions, and if you're just building 10 lines of code, seeing somewhere, seeing some Google and just doing copy and paste, that is not going to help you. That is not going to take anywhere, right? That means you don't have foundations, you don't have fundamental knowledge about this, right? Anybody can just copy the code from GitHub or somewhere and just do that. Okay, so that's not our goal, not our goal. So to go back and to focus on stats, so now I think you might be able to understand, so what is important of stats, right? Fine. So with that, let's see. So from today I am planning to format the class, like I will be teaching like around 10-20 minutes, okay, and after that we will take doubts, okay, like few minutes if you guys have some doubts, and then we will be going for another 20 doubts and 20 doubts. Okay, so that we'll make sure that you are understanding each and every concept. Fine. So as I was saying, I'm going to do what all it is required from my end. Okay, for you guys to make stats as easy as possible and as understandable as possible, and as interesting as possible. Okay, because I have studied stats from different sources. Okay, initially when I studied stats also, as I said, it's not very clear to me. Okay, then I try to collect, understand it, analyze it from different sources, and I think now I have some decent knowledge about stats. Fine. So I'm going to deliver everything. Okay, so but from your part, you need to be interactive. You need to make sure you understand any concepts, every concepts, and make sure if you're not understanding, start asking doubts, fine, and like not missing the classes and being on time, and okay, focus after the class practice, okay, like coming out the doubts, that will be expectation from my end. Okay, so let's make sure uh, this will also be going to be a fruitful module as Python, fine. So I would say that would be the introduction about stats. Any doubts, guys? Basic doubts.
No, Santosh.
Okay, fine. So with that introduction, I would say let's try starting the stats. Okay, so fine. So let me start the stats class. Fine. Let me. Yeah. So initially, as you can see, stats. So, but before coming here, see, but stats, I don't think it's a very new thing for anybody. Okay, just coming out of from this ML or data science part, it, with common word stats is very normal to everybody, right? So what is the stats, right? So you might be, see, everybody might have used stats in their life, but they're not just aware of that. Okay, they don't think that stats. Okay, for example, see, in cricket, what does they do? Everything about cricket is stats. The whole thing about except the game what we are seeing over there, so everything is stats in cricket, right? So what is the run rate? Okay, how many runs are required, right? What is the average score? Okay, or everything you see on the scoreboard is actually stats, right? And for each player they will give you 100 stats, right? They will give you 100 stats. What's his best score in that match? What's his least score? Okay, how many wickets he need to take to reach this milestone, that milestone, overall matches, some graphs you will see, some pie charts you will see, right? Everything you are going to see, it's like completely coming from stats, right? And for example, if you say some people okay, or yeah, so let's say it's a rainy season, and people are predicting, okay, it might rain tomorrow, right? So the rainfall might be severe, okay, and it might be in the range between 7 to 8 on this particular scale. Or if earthquake happens, right, so they might be saying this is earthquake range, okay, volcanoes, okay, or anything. And even for the gold rate, for example, gold, even for the gold rate also, they, what they say, yeah, it's declining this much, it is increasing this much, right? Petrol rate, everything you see, right? So I'm just giving you a normal example just to make sure the stats is not completely new thing. So you already know, you've been using, everybody might have used, right? But only thing is you don't actually call it stats. Okay, it might be considered as a simple math, etc. Okay, but now we are going to study from technical point of view. Okay, the same concepts we are going to take it to next level. Okay, so now if you see, what is the fundamental use of stats is, from date, something you have, let's say you have data. Okay, you have data, right? If data is everywhere, okay, I think you might have heard data is a new oil, okay, data is a new gold, okay. So you see that ads, right, on the computer, so on the YouTube. I see Sirisha joining and disjoining. Hey Sirisha, all good? Hey Sirisha, make sure you have good connection, right? Because this is important. Okay, so now let's say we are having data. So everything will start with data, right? So without data, what you can do, right? So now, if you data is data, but with plain data you cannot do anything. Okay, so once you apply something called as stats, right, what comes out of it is called information. Okay, so with data, okay, with data you might not be able to understand much of it, right? But information is different from data. Stats is the thing, which will convert the data into information. Okay, so means what? So it is raining. Okay, it is raining. That might be data. You might be getting, hey, it's raining in so and so place. That's a data. But stats can say you, hey, actually it's raining at, let's say, some reading, right? I don't know what they call, but let's take it from 1 to 10 scale. Okay, 10 is heavily raining, 1 is very slightly raining. Okay, it's raining like 7 at level 7. Okay, over this place. Okay, and it is raining at level 10 in this place. Okay, it will give you some useful information so that you can analyze it, you can take some action based upon that. Okay, so from raw data, okay, from raw data, using stats, you can able to convert the data into an information. And information is the thing which is a useful data. You can also call it as useful data, or on which data you can try to analyze, okay, and extract some useful information. Okay, fine. So let's go through some concepts of stats. Fine. So initially, yeah, stats is a science that deals with methodologies to gather, review, analyze, and draw conclusions from data. Okay, with specific statistic tools in hand, we can derive many key observations and make predictions from data in hand. Okay, fine. In real world, we deal with many cases where we use statistics knowingly or unknowingly. Okay, as I said, you know, as I just given different examples of gold or petrol, you all the time you're using stats itself. Okay, but you don't call them as stats. Okay, for example, let's talk about one such classic statistic in most famous sports in India. Yes, it is cricket. Okay, so what makes Virat Kohli the best batsman? Jasprit Bumrah the best bowler. Okay, so when they need to declare, okay, this guy is the best, that guy is best bowler, batsman, obviously they need to go through lots of statistics, right? So let's say, see, as you can see, I don't know how many people have watched yesterday match, okay, India Australia match, but every step of the match is completely filled with stats, right? So this diagram, from where you will get this diagram, right? It's stats. You need to understand, right? So which area is maximum scoring, okay, or which area the fielder is hitting. Okay, see, all these diagrams, all these distributions or fluctuations is coming from stats, right? So based upon this, so for this, if you do this for 10 players, obviously you can clearly say who is the best, who is the worst. Okay, and using this simple stats, okay, using the simple stats, fine, so you can clearly say which field he's hitting more. Okay, for example, this is a hitting region of Virat Kohli. Okay, Virat Kohli, and see, he's hitting some runs is a data. Okay, but with stats you can also do some visualizations like this, and as you can see, he's hitting more, let's say, in this region. Okay, in this region. Okay, and he's hitting nothing in this region. So obviously you can employ more number of fielders in this region. Okay, and you can ignore this region for that matter. Just a simple example. Fine. So obviously you are getting some useful information, right? You're getting some useful information, right? So which can give you some fruitful results. Fine. So that is the basic example of stats, I would say. Fine. So as I said, stats is everywhere. Okay, and fine. So we are going to see different methods about the stats. Okay, fine. So now coming to stats, fundamentally there are two types of stats. Okay, fundamentally there are two types of stats. For example, okay, so yeah, but before that, okay, sorry, actually I thought of saying you before that, let me give you an index, guys. Okay, what are you are going to study in stats before actually starting the stats? Okay, so that you will have a high level overview. Okay, what are you are going to study, then you can recognize the names when we are discussing those concepts. Fine. So let me tell you this first. Okay, first thing is we are going to see, as I said, in stats intro. Fine. Second thing is we are going to study types of stats. Okay, types of stats. Thirdly, we are going to see types of data. Okay, types of data. Next, we will see central tendency. Okay, central tendency. In here we are going to study mean, okay, median, fine, and mode and range. Okay, small concepts. Then we are going to study, okay, then we can study something, the statistical measures like variance, okay, standard deviation, okay, and few other concepts. Fine. And then we are going to study what is a sample, okay, what is a sample, and what is a population, okay, what is sample and what is a population, okay. And there is one concept over here which is called yn minus 1, okay, yn minus 1, okay. So we are going to study this. Fine. And oh, I don't have the notes to write. Okay, fine, let me write it over here. Fine. So next we are going to study something called as probability distributions, okay. Let me just call it as PD, okay, probability distributions, okay. Next we are going to cover something called as percentiles, okay, percentiles. With these percentiles we are going to see something called as box plot, okay, box plots. And then we are going to study something called as outlier, and then IQR range, and how to handle outlier, okay, how to handle outlier, okay. These are still the basics, and once you are good with this, okay, then you are going to study something called as normal distribution, okay. Even though you are going to study some distributions in probability distribution, but there are some important distributions which needs special care, and that's one of them is normal distribution, and another thing is standard normal distribution, okay. And here you are going to study something called as z-score, okay. These are extremely important. And then you are going to study something called as central limit theorem, okay. And then you are going to study about something called as correlation, okay. And then you are going to study about covariance, okay. And then you are going to study about something called as point estimates and confidence levels and confidence intervals, okay. And then you are going to study something extremely important concept called as p-value, okay. And then one more extremely important concept called as hypothesis testing, and here you are going to study different kinds of tests. Fine. And then along with that, I'm also including something called as linear algebra, okay. So like you will see how you can play with the matrices. Fine. And few more concepts. Fine. So this is the overview of stats we are going to cover, guys. And believe me, if you are able to follow all these concepts and able to grasp, even not 100%, but at least let's say 80% of what we are discussing, okay, aim for 100, but I'm telling the fact. So like if it is 100%, so I understand that sometimes it might take some more effort for you from your end, okay. So let's say you're understanding 80 to 90%, fine, and we are practicing well, and okay, like making some good notes, fine. So if you're able to complete this, believe me, you will have a very good knowledge about stats, and stats is not going to scare you, okay. So you'll have a very good knowledge about stats, and it will increase your confidence, and machine learning will be very easy for you, okay. So that's the overview, guys, and this is a high level topics, and here and there you might get some more new concepts also. Fine. And almost every concept will be used in some other concept. Fine. All this will be continuation relation, okay. You will use types of data will be used in this concept, mean and median, okay. Once you understand mean and median, okay, that will be used over here, okay. And this is overall concepts about population mean, probability distributions are very important. And then you need to understand the percentile. Using this percentile only, you will do this IQR, and you will also handle outlier. And then one of the probability distribution with normal distribution. From normal distribution only, you'll understand standard normal distribution, and from there only you will get the z-score. And central limit theorem is one more type of distribution. And using all this concept, what all you have studied, you'll try to focus on something called as correlation, covariance, okay. And then you will have coming from here the point estimates, confidence level, this will be like extremely important concepts and something you will have, right? So you have something, I'll put a star for this p-value. As you can see, p-value, right? So if at all you are going for a stats interview, so I don't think there will be any stats interview without the question like what is p-value, right? So every stats interview they'll ask what is p-value. And hypothesis testing is completely in, I have written, just I don't have space over here, but hypothesis testing itself has like many concepts to understand, and it will be very new concept for you to understand. And inside that you have many lots of things, and then you should also have some knowledge about the linear algebra. Fine. As you can see, there is a good flow, nice flow between all these concepts, right? So that you can take it one at a time, okay, step by step. Fine. So, but here, any doubts, guys? Because you guys might have already seen something about stats, okay, or studied. Some of you might have studied about the stats. Any basic doubts? Or as I said, obviously we are going to start it from complete basic, assuming that you guys don't know anything. But still, like 10 seconds for any doubts. Anybody? Sirisha, you are. Oh, I can never hear your voice. You will unmute. You will try to say something, but I cannot hear. Try to make sure you have good connection, because I would say at this point of time in your life, this will be the most important thing, right? So I think then you should give or required attention or money or anything. I think you should give to the class, okay? Because this will help you in your career, okay? I think after your college, if something is going to help you, will be this class or course, okay? So at least for that reason, you should make sure you have a good connection. Fine. So yeah, I can't hear you, Sirisha. You can go on mute. Fine. So fine. So I think everybody is good. No doubts. No general questions. Nothing. Okay. Fine. Let's start. Okay. Fine. Let's start. So to start with statistics. Okay. To start with statistics, let me right. Initially, it is divided into two types, guys. Okay. Descriptive and inferential. Okay. And inferential. Okay. The whole stats is broadly divided into two: descriptive, inferential. Now, what is descriptive, what is inferential, we'll try to see. If at all you are able to derive something from the given data, okay, and if you're able to just describe what's happening, fine, but you are not able to predict using the data, or you're not trying to extract any useful information from that, okay. If it is just descriptive, that means whatever it's happening, fine, so you are just describing that, fine, so that will come under descriptive statistics, okay. For example, for example, let's say here let's say, if at all you are saying based upon the gold rates, you might say, hey, yesterday gold rate is 50K, fine, today gold rate is 55K, okay, and last week gold rate is 48K. For example, if you are saying this, you are just saying this, okay. This is descriptive statistics. That means you are just describing whatever the rates they over there. You have gone through some survey or gone through some news or media, and you are just describing, hey, these are the rates. That's fine. But using this, what we can do? As of now, we cannot do anything. Okay, this is just descriptive. If you are just trying to understand, you are just describing something. Coming to inferential, guys, from the given data, whatever the descriptive data you are giving, if you are able to come up with something which is not present over here, okay, if you're based upon this data, if you're able to come up and tell a new thing based upon this data, then that is inferential. That means after analyzing this trend, if at all you say, hey, with this trend, I am predicting or I am proposing that in 1 month, the gold rate will reach 1 lakh. Okay. Or in 2 years, we are going to face gold scarcity. Okay, we are going to face gold scarcity. Or you can say, if the trend continues this way, okay, let's say it is decreasing. Okay, if it is decreasing, okay, if the rates are extremely increasing, okay, if you see from 48, 55, and if it is increasing, you can say by the end of this year, end of year, the sales might drop to 50%. If you're able to say this, right, these are not present in this data. Agree? The data is there. The data is what? Today rate is this, yesterday rate is this, tomorrow's date is this. That's fine. That is descriptive. You're just describing. That's it. But from the available data, if you are trying to come up with a new thing, okay, like in 1 month, the rate might increase to 1 lakh. This 1 lakh is not present over there. This is your prediction, right? We are trying to inference something. And if you are able to say, hey, in 2 years, you might face gold scarcity. Okay. But that is not present over here, right? So you don't have anything related to scarcity over here. But from this data, you are able to analyze, okay, and understand this might happen. And by the end of the year, if the increases are increasing, rates are increasing like this, the sales might decrease by 50% if you are able to predict something. Okay, that will come under inferential statistics, guys. Okay, so that's a basic concept difference between descriptive and inferential. Okay, we will see some examples so that you will have good understanding. See, the type of statistics dealing with numbers, okay, numerical facts, or to describe any phenomena. Okay, these numbers are descriptive statistics. Okay, just to describe something. Okay, to describe, that's it. Reports of industry production, cricket batting averages, government defeats, movie ratings. Okay, all these are just giving you information, and they are just descriptive. Fine. Inferential statistics is a decision, estimate, prediction, or generalization about a population based on a sample. Okay, fine. So we are going to see a population is a collection of all possible individual objects. A sample is portion. Okay, we will come back to population and sample. Don't worry. Okay, but just to let's first try to understand what is inferential. Okay, inferential is used to make inferences from the data, whereas descriptive simply describes what's going on. Okay, this point is important. Okay, descriptive statistics will help you to make some inferences from the data, but descriptive will only describe what's going on. That's all. Okay, we'll see some example. Okay, so that you will get a good idea. See, suppose in your college there are 1,000 students, and you are interested finding out how many students prefer eating in college canteens or college mess. Okay, so college lo 1,000 members unnaru. You want to know enta mandi they're preferring to eat in college canteen or mess. Fine. Now a random group of 100 people is selected. Okay, and our population size is 1,000 students and the sample size is 100. Okay, so now it's time to study a small new concept. So we will go into detail about this, but since we are coming across this, there are two fundamental concepts in statistics. Okay, it's called population and another thing called a sample. Okay, so as I said, every word, every new concept you are going to study, right, is very, very important. Okay, as I said, you are going to study only that stats which is very important and which is very much needed for the ML or for your future work, right? So that's why any new concept you are giving, you should be very curious and right, should be in a position to understand. Fine. So now one fundamental concept in stats is population and sample, because whatever we are going to do is on what? It's on data. Agree? It's on just some data we are working. Okay, we are trying to do everything. What all we want to do, we are going to do on the data. Agree? But now the data, now the data can be anything, right? So sometimes I'll give an example, guys. Okay, so I'll give an example. For example, my aim is to find out the average height of human beings Okay, average height of human beings in the world. Okay, understanding? My goal is to find out average height of human beings in the world. So now, even if you, for example, even if you go for search for average height of people, okay, for example, see, if I just go here and search for average Indian height, okay, what I'm getting 5'6", 5'7", I'm getting, right? So come back. So he's saying average height is 5'7", 5'7", 5 feet 7 inches. Now question is, how does he know that? Did he go to each and every person throughout the India, calculate the height and did that? See, what is average, guys? What is simple average? If you know, average is what? Sum of total by total. Sum of total by total. Right? So if you're having 1, 2, 3, 4, what is the average? 4, sum 4, 5, 6, 7, 8, 9, 10 by 4. Right? What is this 10 by 4? 2.5. 2.5 means you will get somewhere over here, 2.5. Okay? Average formula ade kada. Sum of the all numbers by total count of the numbers. You will get the average. Getting here also, if my aim is to find out the average height of Indian people, okay, for example, let's take at least only India. Okay, so now average height of India, actually what should happen to find out this average? I want the height of every person, right? If you are starting from person 1, and if I, as of now, population is 140 crores, person 140 crore, last person, everybody height I want, and I should do sum, correct? The formula will not change for India or for America, right? It will be same. So for 140 crore people, heights, whatever the height could be, starting from what is the smallest height? For example, I'll take 4, and highest maximum height I will take as 6, 4 feet, 7 feet, and below, sorry, between this you will have all range of heights. Fine. So the ideally, if you want 100% correct answer for average height, what you should do? You should do the collect 140 crore heights, sum all those 140 crore heights, you will get the sum, and divide by 140 crore. Whatever the value you are going to get, that is the actual average height of Indian people. Getting, guys? Are you able to understand what I'm saying?
Yes, Santosh.
Fine. But do you think, is this the way they have done in Google? When I search for average height, they got something. It is showing that 5'6", 5'7", right? So do you think that they did, like, they went to each and every house? Okay, they took their height, every state, every village, every city throughout the India, and calculated this? No, obviously no. I see something in the chat. Yeah, correct, Sirisha. Yeah, no, they did not do that. Fine, but still they are able to say that. How? So that is where the population and the sample will come into picture. Okay, so many a times, even in stats also, to do all the, to apply many things, right? Here we have applied only average, okay, but let's say we are applying different things. It is, it might be, first thing is, it might be difficult, okay, it might be difficult for us to initially have whole data. Okay, first of all, you cannot have the whole data. So who are going to, let's say, at least for India, you have calculated. If you want for world average height, who are going to visit complete world and collect heights? Okay, it's difficult to get access to the whole data. Second thing, even let's say hypothetically you have got, right, it's not, it's very inefficient. Okay, inefficient for your time, energy, resources, right? It is not worth doing that. Fine. So that is a reason, we have this concept called as population and sample. Okay, population and sample. So now I think you got the basic idea, background of population sample. Now what I'm trying to say over here is, population is the overall population. Sample is a subset of this population, you will take, okay, and you will call this a sample. Fine. Because it is not practically possible to work always on population, right? It is not practically possible to always work on the population. Fine. So we will take a decent collection of items from this population, and then we will call it a sample. And whatever values you are going to get on this sample, okay, we are going to get this on this sample, we will assume they are, if not 100%, they are very close to population. Fine. So other option kada ippudu manaki ippudu how did they calculate now if I tell you like how did you why it is showing as 5.7 in Google or in overall India, right? So what they will do, they in each state they will collect some sample. Okay, so in India, if at all you're having like 30 states, for example, okay, from each state when they do survey, so from each state, let's say they will calculate 1000 people. Okay, 1000 people including everything. Okay, that sample should include everything. That means you cannot include only female population, only male, only child. Okay, not like that. So it will make sure that it will include all different kinds of categories that is available. From 30 states they will collect 30 samples, and then they will take the average of this. Okay, from that you will get an average, if not exact, but this is still average, but that's the only option you have. You cannot go and collect 140 crore population heights, right? What will be the next best solution, right? So next best solution is to take a sample of from that whole population. Okay, now 140 crores is the population, and let's say you are collecting 1000 samples from each and every state, and overall you will have 30 samples. So it means 30,000. Okay, 30k samples is the sample. Okay, this is population, this is sample. Now whatever values you are going to get on sample, right, whatever values you are going to get on this sample, fine. So you will assume that will be pretty much close on this population also, because this sample is now like a representation of population. Okay, this sample is now like acting as a representation of the population. Agree? So when it is not possible to collect, or when it is not possible for you to work on the overall data, you will have something called as sample. So overall data, we'll see more about the sample and population in future classes, but as of now it's enough to understand the overall data will be called as a population. A decent collection of this will be sample. So what all you are going to do, you will be going to do it on the sample. Okay, so with this, let's see an example. Okay, so now as I said, suppose in your college there are 1000 students. Okay, now this 1000 students is the what? 1000 students is the population. Overall 1000 you have. Okay, so to even 1000, see, forget about lakhs, forget about crores, guys. Even to analyze 1000 people individually also, it's very difficult, right? So 1000 is the population, so I don't want to go for 1000, so I'll take only 100. Okay, now I'm randomly taking 100 students from here. Now this 100 is my sample, so the random group of 100 is selected. So that's why here the 1000 of students is the population size is 1000 and sample size is 100. Okay, so now we have done some survey. Okay, survey చేసినాం కాలేజ్ కి వెళ్ళి. దాంట్లో ఏం తెలిసింది? See, this is interesting. This is first year students, second year students, third year students, fourth year students. Okay, so దాంట్లో first year students, people who are eating in canteen are 7 people. Mess lo 2 numbers తింటున్నారు. Coming to second year, 13 people are eating canteen, 8 people are eating mess. Third year, fourth year. Okay, total this much. Okay, that means what? If you see, the total people eating in canteen are 72. Total people eating in mess are 28. Okay, agree? And overall, how much is this? 100 people. And what is the count of second year students? 21, right? Third year 25, right? Like that. If you count, you will get 100. Fine. So this is a statistics. Fine. So now this is what, how did you get? You just did some survey. You went to college, you went to canteen, you went to mess, you did some survey, collected some data, and you're displaying here. Agree? Now this is just the descriptive stats. This is just the descriptive stats. That means you are just describing. ఇంకా మనం దీంట్లో నుంచి ఏమి ఇన్ఫర్ చేయలేదు కదా, మనం ఏం ప్రెడిక్ట్ చేయట్లేదు, మనం ఏమి ప్రపోజ్ చేయట్లేదు కదా. సో యాజ్ ఆఫ్ నో దిస్ ఇస్ డిస్క్రిప్టివ్ స్టాట్స్. విత్ దిస్ డేటా, see, as you can observe, if you go deeper, you will understand some traits, some patterns. ఇక్కడ చూస్తే ఫస్ట్ ఇయర్ లో ఫస్ట్ ఇయర్ లో 7 people are eating in canteen and 12 people are eating in mess. అంటే ఏంటి? Most of the people are eating in mess. But if you see the trend as we go to 4th year, the people who are eating in mess is decreasing. Second year lo 8, third year lo 5, fourth year lo 3 members are eating. Similarly, if you see first year lo 7 people are eating in canteen, second year lo 13, 20, 32. As you can see, there is an increase, and this is also common, right? ఎందుకంటే ఇనిషియల్ జాయిన్ అయినప్పుడు మన దగ్గర మనీ ఉండవు ఫస్ట్ ఇయర్ లో, సో వేరే ఆప్షన్ ఉండదు కాబట్టి విల్ గో అండ్ ఈట్ ద మెస్. అండ్ సెకండ్ ఇయర్ థర్డ్ ఇయర్ ఉన్నప్పుడు some will able to have some money from here and there, right? Slowly, and also we'll stop, we'll lose interest in mess, and slowly we will go and eat in the canteen, right? By the 4th year, as you can see, most of the people are eating in the canteen. Agree? Very less people are eating in the mess. 4th year ki వెళ్ళినాక over ఇంకా mess లో తింటారు అని చెప్పి. Fine. So as you can see, if you see the trend for the canteen, if you see for the canteen, okay, as you see 1, 2, 3, 4, okay, it is increasing, okay. But if you see the mess, okay, for mess only if I draw, so from mess, as you can see from first year the mess is more, but it is decreasing. Fine. So from the single graph, you can understand many things, right? You can understand many things. What is increasing, what is decreasing, okay, which year. Fine. So this is still descriptive. You have to understand this is still descriptive. Now, yeah, as you can see, this is the overall population, and this blue color is what? Blue color is canteen eating people, and red is mess eating people. Okay. In first year, how many people are eating? See, first year blue color is what? Canteen, right? So it is very small, and blue is gradually increasing, and it is becoming very big by the time we go to 4th year, and mess is decreasing. And this is the overall, this is the individual. Fine. So this is the details. Now if you see, if you try 72% of the students prefer eating in the canteen. That means what? How they are saying? See, overall 100%, so people eating in the canteen are 72. So 72 means 72%. Okay, 72% we are able to get it from the canteen. But this is still descriptive statistics, guys. We are not proposing any new thing. Okay, of all the total students who prefer canteen, 44% of them are from the 4th year. Okay, so how is saying? See, overall people are 72, or see, overall people who are eating in canteen are 72. Okay, and 32 people are eating in the, okay, by into 100, 44.4. So 32 by 72, you will get 44.4. That means 44.4 people are eating from the 4th year. Agree? Of total students who prefer eating canteen, 72 are from 3rd year and 4th year. Okay, that means what? If you do for 20 also, if you do for 20% also, that means what? 20 by 72, okay, into 100. Okay, and if you add this to what did you get? 44.4. okay, some 72.1%. okay, this percentage of people, 72% of the people are eating combined 3rd and 4th. First year students are mostly inclined to eating in the mess. As you can see, yes, first year people are mostly eating in the mess. Okay, mess. Fine. Now the above statistics given us a trend of variation among the students with the preference, and we are using the numbers. Okay, and this is still a part of the descriptive statistics. Fine. But now with this data, ఏదైతే మనం చెక్ చేస్తున్నాం, with this data, what you can do, guys, if you are able to infer something, if you are able to predict something, అంటే let's say you are saying, hey, first year people are not mostly coming to canteen. Fine. So if at all that just as an example, if at all a new contract guy is coming, okay, new canteen guy, you can tell him, hey, focus mostly on the 4th year guys, because those are your actual customers. Okay, from there you will get good profits. Okay, focus on them. Fine. Second thing is, first year guys are not that much coming to the canteen. To encourage them, give some discounts to these guys. Okay, these guys are poor guys, first year guys. Okay, they don't have money, so just give some discounts to these guys so that you can encourage, attract them. Fine. And but 4th year guys, fine, you can focus mostly on these guys and increase some items in your canteens. Fine. So you can do some predictions from here, from the available data that is not present over there. Okay, see, Third and but now suppose if someone is able to open a canteen in your college area based upon this data, third year and fourth year are the main target for the sales of the restaurant. Fine. You can give discounts to the first year guys to increase the count. Since most of the students prefer eating in canteen, opening a canteen can be a profitable business in our college. Agree? Overall. So these inferences you have done guys from the data. This is not available in the data. This is what this is just descriptive statistics. Okay, try to see it from difference. What are the data you are given from this survey, above survey? This you can simply give the it is giving you information. It is just describing, hey, this many people eating here. This is a percentage. That's still descriptive. But from there, if you are extracting some insights, this is a practical application. You are saying for new restaurant opening, fourth and third year are the target. Okay, practical implementation. You are telling, hey, do this, you will get something or you will lose something. Discounts to first year. This discount, this is not present in the data. This is clearly present in the data. That's why it's called just descriptive. But this is not present in the data. You are trying to insight, analyze, and infer. Right? That's why this is called. You can say, hey, opening this will be a profitable business. Okay, if you focus mostly on the first year guys, you will lose because these are not the main targets. Okay, if you're trying to infer something, then that is inferential statistics. Okay, let's see, is this clear guys? Doubts? Clear? Okay, so be quick guys. So so because only when you say clear, so I will have confidence to proceed forward. So is the concept clear? Okay, fine. So now as you can see, you have made some inferences about the college. Okay, so next, for example, let's say you are having the average salary of employees of company 2017 is greater than the average salary of teachers in 2017. Okay, so see what is saying. So this average salary of 2017 is greater than average salary of in 2017. What employee salary is greater than teacher salary, he's saying. Okay, that is just descriptive, right? He's just describing, he's checking some data. But based upon the information, see, for example, by 2030, okay, world will face shortage of water. Okay, but he has studied some trends. He has studied some trends this year, water percentage in the countries last years. Okay, based upon this trends, he is saying 2030 world will face shortage of waters. This is not present anywhere because 2030 we did not come it, we did not face it yet, right? So but if you are able to predict something, then that is called inferential statistics. Okay, so I hope the difference you are able to understand. Okay, you are able to understand basic stats. Okay, and inferential, descriptive, inferential. Okay, I would say those are the topics for today. You got the difference, right guys? Descriptive, inference, everyone. We have an exam today morning. Okay, then you can say it right guys. So when you can say it right, yes. Okay, fine, take care, bye.